Greetings iCampSA students, and once again welcome to another video and another lesson from iCampSA mathematics. And today we'll be doing some questions from the past paper of 2018, and the questions will be focused on the topics we are currently covering, which is geometry, analytical geometry, and Euclidean geometry. And also I think we'll touch on some trigonometry as the time allows. Okay, so without wasting any more time, let's get into the first question. Okay, so let me just zoom in so that we can see the statement. Okay, so for question 2, the statement reads as follow. In the diagram below, P, those are the coordinates, Q and R are the vertices of a triangle such that PQ is equal to QR. PQ meaning the distance from P to Q is equal to the distance from Q to R. So the length of those two are equal, and PQ is perpendicular to QR. So as we can see by that 90 degrees angle there, that these two are perpendicular to each other, and T is a point on Q such that T is the midpoint of PQ. So here is our T, which is the midpoint of PQ, and S is the point of intersection. S is the point of intersection of RQ with the x-axis, and V is the point on the x-axis such that QSV, this angle here, is 121 degrees, and then QPS is our here's our QPS. Okay, this angle theta there, yeah, so QPS is equal to angle theta. Okay, that is what we are given, and we have already been told a few things, that T is the midpoint, which would make QT and PT to also be equal. And then another thing maybe to note, okay, since this is a right angle triangle, we can use the Pythagoras theorem to find the sides of the triangle. But okay, let's just get into questions. Okay, so for question 2.1.1, determine the length of PQ and leave your answer in set form. Determine the length of PQ and leave your answer in set form. So right now we are asked to determine the length from P to Q, that length that I just highlighted there. And so since we are given the coordinates of P and Q, we can use the distance formula in order to calculate the length of PQ. And then let's go ahead and do that for 2.1.1. okay, I'll just try to squeeze it in here. 2.1.1, we're asked to calculate the length of PQ. We're gonna say PQ, distance of PQ or length of PQ is equal to XP minus XQ squared plus YP minus YQ squared, or let's just also square PQ here. Let's square PQ. I wanted to write the square root, but it's gonna be a little bit longer. Okay, and then let's go ahead and plug in our values. Since we have everything, this is the distance formula. We can actually note that this is the distance formula we are using here. I think they're also gonna be giving you the distance formula on your formula sheet. Okay, and then let's plug in the values. P is 1 and 0, and Q is 6 and 3. Okay, this is equal to P1 minus 6 squared plus Y0 minus, I think it's 3, yes, minus 3 squared. Okay, and then let's calculate. What do we have here? We have 1 minus 6 is gonna be negative 5 squared is gonna be 25, plus 0 minus 3 is negative 3 squared is gonna be 9. This is equal to PQ squared, and then we have to remove that square by introducing a square root on both sides. So therefore PQ is equal to 25 plus 9. 25 plus 9 is gonna be 34. It's 34, so we're gonna have a root 34, and then we're asked to leave our answer in set form, so this is gonna be our final answer. I forgot to write 34 units. Okay, and that is how we go about solving for 2.1.1. okay, and then next we are asked to calculate the gradient of PQ, and also for the gradient of PQ, since we have both coordinates of P and Q, we can simply just use the gradient formula. Okay, let's go ahead and do that for 2.1.1. 2.1.2. so MPQ, in other words, the gradient of PQ is going to be equal to, remember that the gradient formula is y2 minus y1 over x2 minus x1. In this case, we're going to have yp minus yq over xp minus xq. Okay, this is going to be equal to, let's take the y coordinate of P is 0 and 3, so 0 0 minus 3 over x coordinate is 1 minus 6. 1 minus 6. Okay, that is it. Okay, and then we just punch that in our calculator. 0 minus 3 is going to be negative 3. 1 minus 6 is going to be negative 5. Therefore we're going to have 3 over 5. Just the 3 over 5, we have positive 3 over 5. And also when we look at our line, we're expecting a positive gradient, because remember, if our line is landing in this manner, it gives us a positive gradient. But if maybe we were to calculate the gradient of this line, maybe TR, since it's sloping in this manner, is going to have a negative gradient, but we're going to get into that. For 2.1.3, we are asked to calculate the coordinates of T. And remember that we were told that T is the midpoint of PQ, so we can use the midpoint formula in order to calculate the coordinates of T. Okay, for those who don't remember, this is the midpoint formula. It's we're in 2.1.3. So basically we just take the x coordinates and then we divide by 2, or in other words, we just find the average of the x coordinates, and then we also take the y coordinates and divide them by 2. We add them, we take actually the sum of the x coordinate, divide them by 2, and also take the sum of the y coordinates and divide them by 2 to find the midpoint. So in other words, what I'm saying is this: for the x coordinates of T, we're gonna take, what are the two coordinates that we have? It's Q and P. We're gonna take xp plus xq divided by 2. This will give us the x coordinates of T. And then for the y coordinates of T, we're gonna take yp plus yq over 2 divided by 2, and that is how we calculate the midpoint formula. I forgot to write here that we were using gradient formula. This is the gradient formula, and here we are using the midpoint formula. Maybe I can put this here. I'm saying we are using the midpoint formula, Okay, let's quickly plug in the values and calculate the coordinates of T. X for P is 1 plus x for q, I think it's 6. Yes, it's 6 divided by 2. And then for the y coordinate, y for p is 0 plus 3 divided by 2. Therefore, we're going to have 1 plus 6 is 7 over 2. And then 0 plus 3 is going to be 3 over 2. Therefore, the coordinates of t are going to be 7 over 2 and 3 over 2. Those are the coordinates of t, the midpoint of p and q. Okay, and then next we are asked to calculate the area of QTR. Let me quickly copy so that maybe we can paste it here. Okay, I think we are still, let's drop so that we can just focus on what we are looking for. Okay, we can also drop this, and just be left with 2.2. We are asked to calculate the area of QTR. Let's go ahead and quickly highlight the triangle QTR. The triangle QTR is gonna be this one. QTR is gonna be this triangle, that right angle triangle. And remember that the formula we use to calculate the area of a triangle is half base times height. So our base in this case is going to be what? We're going to take QR. And remember that we were told that QR is equal to what? Is equal to PQ. And we have already calculated the length of PQ. It was square root of 34. So the length of QR is square root of 34. And then we know that QT is what? Is the half of PQ. Therefore, QT, in other words, is going to be the square root of 34 over 2. Because the distance from Q to T is half that of PQ. And PQ is square root of 34. So therefore, the half of square root of 34 is going to be square root of 34 over 2. So we have both of those lengths, and then we can calculate the area of QTR. And I'm saying, in order to calculate the area of a triangle, QTR, we use the formula, which is 1 times base 1 over 2 times base times height, or half base times height. That's how we calculate the area of a triangle. So let's come here. So for area of triangle QTR, we're gonna have 1 over 2 times the base, which is QR, times the base times the height, which is QT. Let's quickly double check. Yes, QR and QT. Okay, and then let's simply plug in the values. We know the length, and remember that to calculate the area we use the length and not the coordinate, or at least in this case we use the length. So we're gonna have 1 over 2 multiplied by QR, which is square root 34, multiplied by QT, which is square root 34 over 2. So here we're going to have the square root of 34 multiplied by the square root of 34, which just give us 34, and 2 multiplied by 2 is going to give us what is this? 2 times 2 is 4. and then I think this can be simplified to 34 divided by 2 is going to be 17 over 2. 17 over 2 units squared. Units squared, since this is an area. We're going to have units squared, whatever units, whether it's meters, centimeters, or millimeters, they're going to be squared. Okay, and then next we are asked to calculate the size of angle theta with reasons. Let's come here. This is our angle theta, and then since we know that angle theta is the angle between the line PQ and the x-axis, we can use the gradient of line PQ to calculate the angle theta. Okay, so we can use the formula, which is 10 theta is equal to the gradient of the line PQ. We already calculated the gradient of line PQ, so I think we can just utilize that to calculate the angle theta in 2.2.1. here. And also I'm looking here, we are given that angle 121 degrees Celsius, which is the external angle of a triangle. So remember that an external angle of a triangle is equal to the sum of interior opposite angles, that angle theta and this angle. The sum of the angle theta, the interior opposite angles, and the angle Q here is equal to 121 degrees, and we know that angle Q is 90 degrees, so we can just use that. And also yes, provide the reason that the sum of an exterior angle is equal to the sum of an exterior angle, the sum of the interior angles, interior opposite angles, is equal to the exterior angle of a triangle. So we just gonna use that. This is 2.2.2 size of angle theta. For 2.2.2, I think that one is the easiest one. 2.2.2 angle theta plus 90 degrees, or we can say it's angle what? Let's look at the triangle PQR plus angle P. Let's put a cap on the Q, is equal to 121 degrees, and I'm saying the reason is the exterior angle is equal to, let's put the reason here, saying the exterior angle is equal to the sum of interior opposite angles. That's the reason. And we know that angle PQR is equal to 90 degrees. Therefore, angle theta is equal to 121 degrees minus 90 degrees. Therefore, theta is equal to 121 degrees minus, let me quickly punch that. I think it's gonna be around 40, or it's 31 degrees. 31 degrees. So that is the angle theta we were looking for. Yes, that's the angle theta that we were looking for. Okay, before we go ahead, we go on to calculate the coordinates of S, we can quickly confirm what I was saying, or let me quickly show you another way of calculating the size of angle theta. If we know the gradient of line PQ, we can use the formula, which is I forgot what it's called, but we can use tan theta, the angle between the line and the x-axis, is equal to the gradient. So let's quickly use that formula. We can use that formula. So another method, we can just say tan theta, the angle between the line and the x-axis, is equal to the gradient MPQ, the gradient of that line. So angle theta is equal to, we're gonna say tan inverse, the gradient of PQ is what, is 3 over 5, and then theta is equal to, let's quickly punch that in our calculator, we get 30.961. When we round off that, we're gonna have 31 degrees. So that is another way of calculating the angle between a straight line and the x-axis. Okay, and then from there we can go ahead and calculate the coordinates of S. And then remember that S is what? S is the intercept. S is the intercept, or the x-intercept of the line QR, So y, we know is 0 there. So I think in order to calculate the coordinate of S, we can use the straight line equation. So we have to determine the straight line equation of QR, and then we solve for S. So, and in order to calculate that, we can calculate the gradient by using tan 121 degrees, or we can use just the coordinates of Q and R. Okay, let's come here. We are in 2.2.3. We are asked to calculate the coordinates of S. The x-intercept. So first thing first, we need to find the straight line equation of QSR of that line. Maybe let me highlight it using another color. Let's find the gradient of that line. So we can either use tan of 121 degrees. In fact, let's just use both methods. First, we start by using the traditional formula for the gradient, which uses the two coordinates of Q and R. Coordinates of Q is 6 and 3, and R is 9 and negative 2. So we have the coordinates of Q, which is 6 and 3, and then the coordinates of R, which is 9 and negative 2. Let me quickly double check. Yes. Okay, let's find the equation of the straight line. Let's start by finding the gradient, which is MQR is equal to YQ or Y2. Yeah, let's just use Y2 minus Y1 over X2 minus X1. This is equal to, let's take any coordinates, take R, so negative 2 minus 3 over 9 minus 6. And also, just by looking at our line here and then the way it slopes, going from the third quadrant to the going from the second quadrant to the fourth quadrant, we can see that we're gonna have a negative gradient here. So let's quickly calculate that. Minus 2 minus 3 is gonna be negative 5, and then 9 minus 6 is gonna be 3. So that is our gradient, and we could have calculated the gradient by using this equation of tan, let's say we just say tan theta, but it's actually tan of the angle between the line and the x-axis, and then angle in our case is 121 degrees. Let me see what is this angle called. We're just gonna call it VSQ. VSQ, tan VSQ is equal to the gradient of QR. Right now we are looking for a gradient, so MQR is equal to tangent of 121 degrees. So this is going to be tan 121 degrees. We are getting negative 1.66. Let's see, negative 5/3. Yes, we are getting negative 1.66, which is also the same as when we convert negative 5/3 to decimal is also negative 1.66. so those two are the same. And then we are not done yet. We are looking for the equation of the straight line, and then the equation of the straight line is y is equal to mx plus c, being while being y and x are the coordinates, and then m is for the gradient, and then c is for the y-intercept. C is for the y-intercept. So we can take any coordinate between q and r to find the c, the constant c, which is the y-intercept. Let's take coordinate q, which is 6 and 3. 3 is equal to the gradient is negative 5/3 times the x coordinate is 6 plus c. Therefore our c is gonna be 3. Negative 5/3 times 6 is gonna be negative 5 times 2, which is negative 10, plus 10, which is equal to 13. That is our c. Therefore the straight line equation of that line PQ is gonna be y is equal to negative 5/3 x plus 13. Let me quickly double check the 13. Negative 5/3 times 6 is negative 10. Then we put it on the other side. Yes, indeed, we're gonna have this equation here. And then we are not done, because we are looking for the coordinates of s, and then we know that s is the x-intercept of that line QR, and then where the line intersects the x-axis, we know that our y is gonna be equal to 0. So we have to solve for the x coordinates of s. We already know that the y will be 0. So let's substitute 0 is equal to negative 5/3x plus 13. Let's put 13 over on the other side. Negative 13 is equal to negative 5/3 times x. Therefore x is gonna be equal to, let's see, negative 13 divided by negative 5/3 is gonna be 39/5. X is equal to 39/5. Therefore the coordinates of s are 39/5 and 0 and 0. Those are the s coordinates. And then from there, let's go ahead and do, what is this, determine with reasons. Okay, the gradient of the line through T, and the midpoint of PR. So we're gonna have a midpoint of what, PR, and then what, and then the line passes, let's say this is, I'll just call it mid PR, the midpoint of PR, and then the line passes through the midpoint of PR and what? And T and the T. So what do we have to calculate here? We have to calculate the midpoint of TR, MPR, and then we're looking for the gradient. Yes, so we need to find the coordinates of the midpoint of PR. We already know the coordinates of T, we calculated them. The coordinates of T is 7/2 and 3/2. The coordinates of 7/2 and 3/, let me use a different color, 7/2 and 3/2. We just need to calculate the coordinates of the midpoint of PR. There, this is not the gradient but the midpoint of PR, and then we can use the coordinate, or we can use the gradient formula to calculate the gradient of that line T, the line that passes through the midpoint of PR and point T. Okay, so to calculate the midpoint of PR, we need to use the midpoint formula. If you remember the midpoint formula, so we're gonna use P and R. The coordinates of P is 1 and 0, and those of R is 9 and -2. 9 and -2. Let me quickly add the page here. Okay, this is 2.3. We are looking for the midpoint of PR. The midpoint of, is it PR or QR? Let me see if I'm not mistaken. Yes, it's PR. We are looking for the midpoint of PR. Okay, and those are your coordinates. Remember to find the x value of the midpoint of PR. We're gonna use the midpoint formula. So the x value of the midpoint of PR is equal to xp plus xr divided by 2, and then the y value of the midpoint of PR is going to be yp plus yr divided by 2. Okay, and then from there, let's plug in the values. The values we have, the x values is, say, let me quickly double check. The x values is 1 and 0 and 9 and -2, so it's 1 plus 9. We're gonna have 1 plus 9 divided by 2, and then the y values is 0 plus -2 divided by 2. Therefore 1 plus 9 is 10 divided by 2. We're gonna have 5, and then 0 minus 2 divided by -2, we're gonna have -1. Therefore the midpoint of PR is what? Is 5 and -1. Now that we have the midpoint of PR and we have the coordinates of T, if you remember, the coordinates of T were 7/2 and 3/2, 7/2 and 3/2 and 3/2. We can now calculate, what were we looking for? The gradient of this line, and by using the gradient formula. So we're gonna say MT and the midpoint. So to calculate gradient MT, the gradient of the line passes through T and midpoint of PR. We're gonna say y2 minus y1 over x2 minus x1. this is equal to, what is y? 2. We can take the one for t is 3 over 2 minus y1, which is -1, divided by 7 over 2 minus 5. This is gonna be equal to, let's quickly punch that on our calculator, plus 1 over 2 minus 5 is equal to -5 over 3. -5 over 3. And there we have the gradient of the line that passes through the line that passes through T and the midpoint of PR. Okay, so we're gonna end this video right here, and then I will see you guys on the next video. Thank you for attending, and I hope you learned something. Don't forget to follow us on all the social media, and also subscribe to our YouTube channel. Thank you.